Hey, boys and girls. Hope everyone's doing well. We're going to go over the mystery footprints real quick. That way, if you didn't get a very good grade, you can watch this video, go over it. I'm going to go over it, and you can unsubmit your assignment and redo it to get a better grade. Okay? So, all right. This says look at these two sets of animal tracks. Now, it does say animal tracks, okay? It says list three observations, make an inference. And again, I'm making those observations right here. Okay. I'm making them there. 1, 2, 3. This is for frame one. Okay. So we can say there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 green animal tracks. We can say there are 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. There are 25 red animal tracks. So again, over here, I would say there are 13 green animal tracks. There are 25 red animal tracks. I need one more observation. Now, you could say it's on a yellow background. You could say the tracks are, the green tracks are going upward. The red tracks are going downward. However you want to say it. So I'm going to say the green tracks are going upward. Okay? That's three observations. Notice I didn't say there are 25 rabbit tracks. There are 13 duck tracks. I didn't say that. I can only, again, an observation is you can only write down what you can observe through sight, touch, taste, smell, or hearing. Okay, now I can't hear this, I can't touch it, I can't taste it, but so the only thing I can do is look at this picture and list three things that I see. Okay, not what I think they are, what I see. Okay, so that's where some of you made a mistake. Now, in frame number one here, you are to make an inference. Okay, so this is where you can tell me what you think is occurring here. So I'm going to say there is a duck and a bird walking toward each other. All right, next slide. Now, what do you think? Make three observations, make an inference. I'm making observations about this slide here. So I can count the animal tracks again. Remember, so those are quantitative observations. I'm just going to make I'm going to make three qualitative observations. Okay. So again, these are quantitative observations because they have numbers in them. This is a qualitative observation. So I see red animal tracks. You could count them. I'm not going to take the time to do that. I see green animal tracks. Then the third observation would be that they're mixed, right? The green and red animal tracks are mixed. Now, this is where I get to say, notice how I'm formatting. Some of you don't do that. I'm just changing my font size. Okay. Now I'm going to say what I think's happening in this picture. Okay. I think this is my inference. There is a duck and a bird. You know what? Didn't I say frog originally? There's a duck and a frog. Sorry about that. Walking around eating food. I think bird goes better. I'm going to rechange that. Jeez, oh Pete's. There's a duck and a bird walking around eating food. Here's why I changed that. Does it make sense if a duck and a frog are walking around eating the same food? Probably not. Okay, so but it does make sense. Inference does make sense. It would be a duck and a bird. Okay, sorry for changing that. So hopefully I'm not confusing you. So there I go. 3 observations, inference. Now I'm going to go through to my third and final frame. Now what I think's happening here. Okay. Well, I'm sorry. That's the inference. I need to get my act together. 3 observations of what I see. Okay. Now I can count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 19, 20, 21, 22, 23, 24. I see 24 green animal tracks. The green tracks are sloping down. The background is yellow. So there are 3 observations. Okay. Again, I'm not saying there are 24 green duck tracks or anything like that. That makes it an inference. I'm just saying what I can observe directly. Now I can go over to frame 3 and I can say what's going on in this picture. So I'm going to say the bird flew away and the duck is now walking away. Now I come down to conclusion. This is where I put all 3 together. This is where I say this happened, then this happened, then this happened. Okay, so conclusion. Again, change the font. There was a duck and a bird walking toward each other. They ate some food and the bird flew away as the duck walked away. Now you could have come up with other stuff, okay? I'm not saying this is right. This is my observations. These are my observations. These are my inferences. And this is my conclusion, okay? Now, I come down here. I have a word bank, quantitative, qualitative, observations, and inference. So one of these will go in one of these 4 blanks, and you can put the answers to that down here, okay? So one of the most important skills in science is the use of our 5 senses or making observations. Most of the time we think of observing as something we do with our eyes. When we see something, we observe it. However, all 5 of our senses can be used to make observations: sight, hearing, taste, touch, and smell. A good scientist is observant and notices things in the world and becomes curious about what is happening. We can make 2 kinds of observations, either qualitative or quantitative. Qualitative data is that is hard to measure, count, or describe in numbers. It describes the qualities or characteristics of something. Examples are colors, taste, and sound. Quantitative data is information that can be expressed using numbers. If information can be counted or measured, then it is quantitative. Tools are often used to collect quantitative data. Examples include amounts, temperature, mass, and length. After making observations, our brains make logical conclusions about our observations called inferences. All right, so that's mystery footprints. Let's go over what we're going to talk about today in class, and it is independent and dependent variables. Okay? All right, again, independent variable. That is the variable that is changed or manipulated in the experiment. The dependent variable is what responds to that change or what you are measuring. So the student wanted to test how the mass of a paper airplane affected the distance it would fly. Paper clips were added before each test flight. As each paper clip was added, the plane was tested to determine how it would fly. So, what is the independent variable? What are we changing in this experiment? Okay, we're changing the mass by adding paper clips to the airplane. What are we measuring? The distance it would fly, the distance the paper airplane would fly. So mass affects the distance it would fly. So we're testing. Hey, each time we put on a paper clip and we add mass, how does that affect the distance the paper airplane would fly? Now, there is one other variable called the control. It's the thing that we keep the same. So in this example, we would do the same plane and the same paper clips. In other words, you can go with one brand of paper clips, add one brand and then add a different brand. It's got to be the same. You've got to have a control. If you don't have a control, the experiment isn't valid and it's not trustworthy. Okay? Two groups of students were tested to compare their speed working math problems. Each group was given the same problems. One group used calculators and the other group computed without calculators. All right. So what are we changing in this experiment? We're changing calculators, right? One group gets them, the other group doesn't. Okay? What are we measuring or what's responding to that change? The speed students have working math problems. Okay? So again, what are we changing? What are we manipulating? That's the independent variable. Okay? So we are changing calculators. One group gets them, the other group doesn't. The dependent variable is what responds to that change or what we are measuring. What we are measuring, what responds to that change, is the speed at which the students are solving or working the math problems. The control, okay? Well, each group would have to get the same exact questions or same problems, okay? Students of different ages were given the same puzzle to assemble. The puzzle assembly time was measured. So what's our independent variable? What are we changing in this experiment? We're changing the ages of the students. Okay. What are we measuring or what's responding to that change? The dependent variable is the assembly time of the puzzle. Now, your control, you'd have to give them the exact same puzzle. You couldn't give them different puzzles because then the experiment would be invalid. Students measured the temperature of the water at different depths in Lake Skywalker and found that the temperature varied. Okay, so what are we changing in this experiment? We're changing the depth of the water. Okay, we're going deeper. Okay, we're looking at, as I go deeper, what happens to the temperature of the water? So what are we changing? The independent variable? The depth of the water or the lake. What's responding to that change? What are we measuring? The temperature. Now the control, same thermometer, and you'd have to stay at the same spot of the lake. Okay, you couldn't move around. The amount of pollution produced by cars was measured for cars using gasoline containing different amounts of lead. Okay, so what are we changing in this experiment? The different amounts of lead. So that's the independent variable. What we change, what we manipulate is the independent variable. What responds to that change or what we are measuring is the dependent variable. So what are we measuring? What's responding to that change? It's the amount of pollution. And you'd have to use the exact same car each time. All right, boys and girls, that is all for today. If you have questions, feel free to email me. Take care.